Hello students, today we are going to do 10th standard geometry second chapter Pythagoras theorem. Okay, in this video I'm going to do only theorems. Okay, so first theorem, similarity and right angle triangle. Second one is theorem of geometric mean. Third one is Pythagoras theorem, and fourth one is converse of Pythagoras theorem. So first one is similarity and right angle triangle. Okay, statement says in a right angle triangle, if the altitude is drawn to the hypotenuse, then the two triangles formed are similar to the original triangle and to each other. In the sense, see, ABC is a right angle triangle. Okay, ABC is a 90 degrees, so triangle ABC is a right angle triangle, and segment BD is perpendicular to segment AC. Okay, so there are two triangles formed. See, ABC is the original triangle, okay, and BD is a perpendicular to AC, so we get a two triangles. So statement says that, see, in a right angle triangle, if altitude is drawn to the hypotenuse, then two triangles have formed are similar to the original triangle. Means triangle ADC, this triangle is similar to ABC, this original triangle. Okay, second triangle BDC, this triangle is similar to ABC. Okay, so therefore triangle ADC similar to BDC, ADB is similar to BDC. These two triangles are similar. This is only we have to prove. So first, given, we'll write in triangle ABC, angle ABC is a 90 degree. Angle ABC is 90 degree. And segment BD, okay, segment BD is perpendicular to segment AC. Okay, this is, see, in a right angle triangle, if altitude is drawn to the hypotenuse, that is, see, segment BD is this altitude, this perpendicular line. Altitude means what? Perpendicular line is drawn to the hypotenuse, that is BD is perpendicular to AC. Such a way that is AC, so therefore A, D and C, A, D, C are collinear. Okay, now to prove triangle ADB is similar to triangle ABC. Okay, triangle ADB is similar to triangle ABC. Here ABC is the original triangle. Okay, then BDC, ABD, okay, ADB similar to ABC. Now BDC, triangle BDC is similar to triangle, original triangle ABC. Then triangle ADB, similar to BDC, triangle BDC. Okay, now proof. See, in triangle BDA or ADB, in triangle ADB and ABC, first take this triangle. Now to prove only this triangle, triangle ADB and triangle ABC. Okay, angle DAB is, this angle DAB is similar to angle BCA or ACB. Okay, in triangle BDA and ABC, angle DAB is similar to BAC. Okay, BAC, because angle A is a common angle. Okay, then angle BDA, this angle is similar to angle ABC, because they both measures 90 degree. Okay, therefore this angle ADB is similar to angle ABC. Okay, therefore we'll write here to prove in triangle ADB, and triangle ADB and triangle ABC, in triangle ADB and triangle ABC, angle DAB is similar to angle BAC, CAA. So because common angle. Okay, common angle, and angle BDA similar to angle ABC, angle ABC, both measures, because both measures 90 degree. Okay, both measures 90 degree. See, these are DAB angle BAC is common angle. Their common angle means they are congruent. They are similar, but even then they are congruent. So you have to put congruent sign here. They are congruent. So ulta. Okay. Therefore, triangle ADB is similar to triangle ABC. So this is equation number 1 can give. They are similar by which test? AA test, by AA test. Okay, AA test. Two tests, no? One is common angle, one is both measures 90 degrees. So they are similar by AA test. Now this triangle. Now we will take this triangle, second triangle. Now we will take this triangle. In triangle BDC and ABC. In triangle BDC and triangle ABC, angle BCD. Okay, or DCB. BCD is congruent to angle BCA or ACB, because they are common angle. Another one is angle BDC. This is BDC. This is congruent with angle ABC, because their measures 90 degree. Angle BDC is congruent with angle ABC. Both measures 90 degree. Okay, therefore triangle BDC similar to triangle ABC by AA test. This is equation number 2. Now from 1 and 2, this equation number 1 and 2, from equation 1 and 2, see 1 and 2, right side ABC, ABC, so write the left hand side. Therefore triangle ADB, okay, is, second one is here BDC, is similar to triangle BDC. Now write only once ABC, triangle ABC, okay. So hence it is proved. So it's triangle ADB, ADB similar to BDC, similar to original angle ABC. Hence it is proved. Okay. So write, hence it is proved. Okay. Now second theorem of geometric mean. Okay. Statement in a right angle triangle, the perpendicular segment to the hypotenuse from the opposite vertex is the geometric mean of the segments into which the hypotenuse is divided. Okay, so in a right angle triangle, ABC is a right angle triangle because angle ABC is a 90 degree. This mark shows that this is 90 degrees, so ABC is a right angle triangle, and BD, segment BD, perpendicular to segment AC, and see, segment to the hypotenuse from the opposite vertex is the geometric mean to the segments into which the hypotenuse is divided. This hypotenuse, this segment divides this hypotenuse, no? So first we'll write given in triangle ABC, okay, angle ABC is a 90 degree and segment BD perpendicular to segment AC such that A to D to C, because it divides, so A, D, C are collinear. They are A, D, C are on a same line AC. Okay, A, D, C. Now prove theorem of geometric mean, that is formula is BD square, this perpendicular line, know that BD square equal to AD into DC. AD into DC. BD square, there in practice at 2.1, many problems are there to find out geometric mean. So you have to use this formula, BD square equal to AD into DC. Okay. Proof in this triangle, in triangle ABC, angle ABC is a 90 degree, so it's a right angle triangle. Okay. Segment BD perpendicular to segment AC, so angle ADB is similar to triangle BDC. This, from where this is, just now you proved, no? Just now you proved similarity in right angle triangle, no? So first we'll write proof in triangle ABC, angle ABC is 90 degree, segment AD, segment BD is perpendicular to segment AC. BD is perpendicular to segment AC. Therefore, angle triangle ADB is similar to triangle BDC. This is from similarity and right angle triangle. Similarity of right angle triangle. Similarity of right angle triangle. Right angled triangle. Okay. So these two triangles are similar. Oh, now write the corresponding sides. Okay. Therefore, write here. Where is the pencil? Okay. See, first write AD by BD. Okay. Then first write corresponding sides AD by BD equal to, then BD here, second DB or BD by here DC or CD, DC. Okay. Therefore, here cross multiplication BD square equal to AD into DC. But here write corresponding sides. Corresponding sides of similar triangles. Similar triangles are in proportion. Okay. This. So BD square into AD into equal to AD into DC. BD square equal to AD into DC. This is the formula. And you have to remember this formula to solve problems also. Even theorem is also important, might ask in the exams. Okay. Second theorem is Pythagoras theorem. Okay. Statement says, in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides. Okay. So you must be familiar with this formula, no? PR square equal to PQ square plus QR square, no? So given is in triangle PQR, angle PQR is 90 degree. Okay. So it is a right angle triangle. To prove PR square equal to PQ square plus QR square. Okay. Now construction, draw a perpendicular line to hypotenuse. Okay. Always construction in a dot lines. Let it be S. Okay. So construction, draw segment QS perpendicular to hypotenuse PR, hypotenuse PR, such that PSR. Okay. PSR collinear. So proof. Now proof, in triangle PQR, angle PQR is a 90 degree. So triangle PQR is a right angle triangle. Okay. So in triangle PQR, angle PQR is 90 degree and segment QS perpendicular to side PR Okay, QS is perpendicular to PR. Therefore, if you see right angle triangle, and this is 90 degree and this is right angle triangle, and segment this perpendicular line, this line perpendicular, a segment perpendicular to hypotenuse or side PR, then according to the similarity in right angle triangle, this is triangle PSQ, triangle PSQ is similar to triangle QSR, triangle QSR similar to PQR. Now this is that similarity in right angle triangle statement. This is PSQ, triangle PSQ similar to QSR, similar to original triangle PQR. Okay, give, this is equation number 1. This is because similarity of right angled triangle, right angled triangle. Okay, so first we'll take this triangle and original triangle. Okay, so in triangle PSQ and PQR. Okay, in triangle PSQ and PSQ is similar to triangle PQR. Now write the corresponding sides of this PSQ and PQR. Write the corresponding sides. PS by PQ, PS by PQ equal to SQ by QR equal to PQ by PR. These are corresponding sides similar triangles are in proportion. Can write corresponding sides of similar triangles are in proportion. Okay, so here now therefore PS by PQ equal to PQ by PR. So you have to omit this. Now cross multiplication, therefore PQ square equal to PS by PS into PR. Okay, PS into PR. This is equation number 2. Okay, now we have to take this triangle. Okay, that is QSR. Okay, therefore triangle QSR is similar to triangle PQR. Corresponding sides QS by PQ equal to SR by QR equal to QR by PR. Okay, therefore SR by QR equal to QR by PR. Therefore QR square equal to SR into PR. This is equation number 2. Here you can write corresponding sides of similar triangles are in proportion. Okay, this is equation number 3. Okay, this is equation number 3. Now adding equation 2 and 3. Equation 2 and 3. Okay, we have to add pq square plus qr square, pq square plus qr square equal to, see, pq square plus qr square, ps multiplied by pr, ps multiplied by pr plus equation number 3, sr multiplied by pr, sr multiplied by pr. So here, therefore, pq square plus qr square equal to ps, here in this pr you can keep out, see, pr, so pr, so ps plus sr. Okay, so ps plus sr, what? ps plus sr is pr, no, here ps plus sr is pr into pr. This is therefore pq square plus qr square. Therefore pq square plus qr square is pr square. No, this is pr square. What we have to prove? To prove that pr square equal to pq square plus qr square. You can write in this way also. Therefore pr square equal to pq square plus qr square. Okay. Pythagoras theorem is very easy. You have to understand the basic theorem, similarity of right angle. The same concept you have to use in this. First you have to take this triangle and this triangle with the original triangle, write the corresponding sides, and then you have to add both. Okay. Now converse of Pythagoras theorem. Okay, statement says, in a triangle, if the square of one side is equal to the sum of the squares of the remaining two sides, then the triangle is a right angle triangle. It is totally opposite of what the Pythagoras theorem says. What Pythagoras theorem says? Pythagoras theorem says that square of the hypotenuse is equal to the sum of the remaining two sides. That is AC square equal to AB square plus BC square. That is what Pythagoras theorem says. But here in converse, totally opposite. What is totally opposite? Given, see, in triangle ABC, if AC square equal to AB square plus BC square, then angle ABC is a 90 degree. That is, triangle ABC is a right angle triangle, that you have to prove. If AC square equal to AB square plus BC square, then triangle ABC is a right angle triangle. If it, okay, see, given in triangle ABC, AC square equal to AB square plus BC square. To prove that angle ABC is a 90 degree, triangle ABC is a right angle triangle, that you have to prove. Construction, we have to construct, we have to draw another triangle XYZ, okay, such that XY, you have to draw another triangle, you have to construct another triangle such that XY is equal to AB, YZ equal to BC, and XZ equal to AC. Okay. Draw XYZ such that XYZ is a 90 degree. It should be a right angle triangle XYZ is a 90 degree, XY is AB, YZ and BC, these two. Okay. Proof. In XYZ, in triangle XYZ, XYZ is a 90 degree. Okay, that is construction, we have constructed. So by Pythagoras theorem, see, xz square equal to xy square plus yz square. No, construct and use Pythagoras theorem, that is equation number 1. Okay, then but xy is equal to AB. No, this is equation number 2, and yz is equal to is BC. No, yz is BC. So in this equation number 1, you have to substitute this xy is AB and BC, yz is BC, that you have to substitute in equation number 1. That is xz square equal to, instead of xy you have to write AB square plus, instead of yz you have to write BC square. From 1 substituting equation number 2 and 3. Okay, so you get this. Now we know that AC square equal to AB square plus BC square. No, this is equation number 5 you give. Then from 4 and 5, this x left hand side xz square and AC square, these are equal. No, that is xz square equal to AC square, that is taking square root, xz is AC. Okay, in triangle ABC and XYZ, segment AB is congruent with XY, segment XY, segment BC is congruent with segment YZ, and segment AC is congruent with segment XZ. Okay, so therefore triangle ABC is congruent with triangle XYZ. Okay, that is these two triangles are congruent by SSS test, side test. This side is congruent with this side, BC is congruent with YZ, and AC is congruent with XZ. So these two triangles are congruent by SSS test. Okay, then triangle ABC, angle ABC is congruent with angle XYZ because they are 90 degree. These are corresponding angles. Okay, so XYZ is 90 degree. Similarly, angle ABC is also angle XYZ is 90 degree. So angle ABC is also 90 degree. And angle ABC is 90 degree. Therefore, triangle ABC is a right angle triangle. This is a very easier one. So these are the 4 theorems are in second chapter. These are the 4 theorems. These 4 theorems are very important. This is a basic one, similarity and right angle triangle. This is a basic one, important one. And theorem of geometric mean you have to use this same similarity, right angle triangle. This concept only you have to use in theorem of geometric mean, and also in Pythagoras theorem also same concept you have to use. Okay, you have to write and learn it. Okay, so okay, then bye.